My nomination for Molecule of the Year is acrylic acid, also known as 2-propenoic acid. First, I want to go over some of acrylic acid's characteristics. Acrylic acid is a simple unsaturated monocarboxylic acid. It's a fairly small molecule consisting of only 9 atoms. It is a clear, colorless liquid at room temperature, and it is miscible with water, meaning it mixes in all proportions to create a homogeneous mixture. Acrylic acid has a molecular weight of 72.06 grams per mole. It has a melting point of 12.77 degrees Celsius and a boiling point of 141 degrees Celsius. Acrylic acid gives off a strong, distinctive acrid odor. It is highly reactive and corrosive, causing burns with contact to the skin and respiratory tract. With extended exposure, acrylic acid can cause pulmonary edema when inhaled. Because acrylic acid is rapidly absorbed and metabolized, it has a short half-life and does not bioaccumulate. It presents low toxicity to bacteria and soil microorganisms in environmental studies. It is also highly flammable. Acrylic acid was first discovered by Ferdinand Redenbacher in 1843 when he isolated acrylic acid by oxidizing acrolein with aqueous silver oxide. Now that we've gone over some of acrylic acid's chemical properties and history, let's go over its uses and claim to fame. Acrylic is used for the formation of polymers. It is used in plastics, coatings, adhesives, elastomers, paints, and polish. It is also used in hygiene, medical products, detergents, diapers, and wastewater treatment chemicals. It is biodegradable under aerobic and anaerobic conditions. Acrylic acid is common and used in a wide variety of industrial processes, commercial and personal uses. It can be easily purchased in craft stores, hardware stores, and online for the general public. Acrylic acid is derived from propene oxidation. Currently, most acrylic acid is obtained from the partial oxidation of propene, which is a byproduct of ethylene and gasoline production. The process of obtaining acrylic acid releases hundreds of tons of CO2 into the atmosphere, contributing to climate change. The global market for acrylic acid is growing, which presents a problem because the petrochemical carbon sources used are limited and non-renewable. Due to its multiple uses and relatively low environmental toxicity, I would generally be inclined to name acrylic acid a hero. However, many of the products it is used to create, such as plastics, detergents, paints, and more, in addition to the fact that the processes used to produce acrylic acid contribute a very large carbon footprint, leads me to name this molecule a villain. Plastics pollute our oceans, and detergents pollute our freshwater systems. Many of the products that acrylic acid is used to produce take hundreds of years, if not more, to biodegrade. This molecule, while inherently useful, would need to have a different process used to obtain it. Active research is underway to develop a more environmentally friendly and economical means of producing acrylic acid using the fermentation of renewable sources via microorganisms.